have a panel of PyTorch maintainers to tell us a bit more about PyTorch 2.0 and how to contribute to PyTorch also. So I'll start with some introductions first. We have Nikita Shulga, who's a tech lead and maintainer of PyTorch, including coverage of the platform support, continuous integration, developer tooling, and best practices. He drove the GitHub first and internal release process at Meta, which unblocked external maintainers to contribute to code on GitHub. We also have Natalia Gilmeshane, a core team lead, expert on PyTorch, including long-term focus on NVIDIA GPUs, performance, profiling, and the new PrimTorch, inductor, and some other parts of 2.0. Then we have Orion Riblitz Richardson. He supports the PyTorch developer infrastructure at Meta, and he's looking at ways to empower the community and core teams to move forward on 2.0, including the launch of the PyTorch Foundation and increased investments on our technical governance. And finally, we have Peng Wu, who supports the PyTorch compiler team at Meta. Our team, with some partners, have built many of the key components of 2.0, including the Torch Dynamo graph capture and Torch Inductor backend. So thank you for being here with us today. So first, what is my code doing differently when running 2.0 compared to 1.x? Natalia.
So this has been covered in a lot more details in the presentations this morning, but very briefly, when we are running the program with PyTorch 2.0, first Torch Dynamo acquires the trace of the program in a sound way. Then it is sent to AOT dispatch to trace through the backward, and then the obtained trace of forward and backward computations is passed on to compilers that are generating efficient code. And that pretty much leads to user experience where you can run your programs as you wrote them with minimal changes and get a better performance through generated efficient code.
Thank you. But I want to get started with 2.0. Like, how do I install it, and are there any additional requirements?
So there is no real additional requirement. So 2.0 is not yet ready, but we have the feature that was announced today available in the latest nightlist. So just go to pytorch.org website, find the Getting Started guide, and just download the latest nightlist. And if something doesn't work, let us know.
Yeah.
Because I believe there would be some.
Perfect. So then, like, I've got 1.x code, and I want to migrate it to 2.0. What do I need to do that? Natalia.
It's pretty simple, as has been shown in this morning's presentations. You just wrap the function or model that you want to optimize with torch.compile API. There are a few switches that let you fine-tune what exact compiler behavior you want to see, but the default options are expected to give you a pretty good speed up, even without fine-tuning.
All right, so I want you all to try that soon, right? Now, Peng, how does distributed training work with 2.0?
So PyTorch 2.0 right now supports FSDP and DDP APIs, but the other distributed APIs like distributed tensor or PP or tau have not been supported yet. And also with FSDP and DDP, there might be some other limitations like manual checkpointing. So, but this development is fast moving, so just keep on checking on our progress, and if you find a problem, found an issue on GitHub.
Thank you. So, what should I do if my previously running code is crashing with 2.0? How do I debug it?
So, well, there are two ways of doing it. First of all, you can disable 2.0, just remove the decorator or pass an environment variable that completely disables tracing. But if you discover an issue, please report it back to us. There is a minifier tool that was mentioned earlier today. Use it to minimize the reproducer and send it to us. It will be very interesting to see what can go wrong.
Perfect. So what are some of the challenges of supporting a broad set of models with compiler techniques?
Well, one big challenge is in the question. We want to support a broad set of models, and that means that we need to support great diversity of different operations. We need to support those operations in very different combinations and still generate the efficient code. So the way we are doing this is, first we are reducing the number of operations that compilers need to support through the decompositions. And that way we reduce the operator set from 2,000 operators that PyTorch supports to something much more manageable, like 200. Then we've developed our compiler with the breadth-first approach. We aim to support all or almost all of PyTorch operations. And that means that we are creating lowerings for all the classes of operations, 200 or so, that remain in the trace after this decomposition process. We are handling pointwise operations, which are really easy to handle, reductions that are slightly more complicated. We are handling indirect access operations, such as scatter and gather. We are handling implicit and explicit broadcasts, slicing views. And that gives us pretty good coverage for all the operations that we are encountering in the wide set of models. Then after this decomposition and lowering process, we actually need to generate an efficient code for the loop IR that we've obtained. And here is where our code gen backends come in. We have a nice separation of concerns where the inductor itself is handling lowering to loop level IR, and then we are offloading the code gen generation itself to establish tools that are known to do a good job of creating efficient code. And in particular, that allows us in Inductor to generate much simpler and readable code and offload the performance complexities to the compiler backends that we have. People who are looking at the Triton code that we've generated usually say that it's pretty simple and readable and one can understand what's going on in the kernel. But the actual magic that would go on to turn it into a performant code that will be executed on the GPU is substantial, and it's just hidden from the view of the users. And I think that this structure with a nice separation between the lowering and actual code gen is something that makes both the developer experience for Inductor better and user experience.
Thank you. Peng, this question is for you. What explorations are we allowing as backends for PyTorch 2.0?
Yeah, so I translate this as the integration points for backends to PT2. We actually have two main integration points. One is at the right after Torch Dynamo. So if you have a mature backend that can handle a lot of ops, you can integrate at that level. So basically, we hand the graph over to you, and you compile and execute. And another integration point is deeper into the stack to integrate at the Torch inductor level. This is suitable if you have a new backend and you want Inductor to take care of more of the things. And also we have a third option. If you do have a mature backend, but it only handles a subset of ops, we are experimenting with a hybrid model where Inductor handles part of it and will also offload the part that you are good at so that we can have two backends in the same place. Again, go to the blog post where we will have more description on where to integrate and when.
Great, thank you. Switching gears a little bit here, we moved to GitHub first development. And Nikita, can you tell us a little bit about this project and about PR best practices and maintainer best practices in general?
Sure. So if you want to, what changed with GitHub first is that before that, to merge your change into the PyTorch code base, we first need to go to the internal integration at Meta. But as we move to Foundation, as we move to GitHub first, we can just allow everybody to propose a PR and allow anybody outside of Meta to become a maintainer, so be a reviewer for the change that is proposed, and landing this change without any intervention from a Meta engineers. That allows us to move much more faster and build a more diverse ecosystem.
That's a pretty big change. We're giving the power to maintainers now. So talking about how this works and governance in general, Orion, can you tell us more about the difference with the PyTorch Foundation business governance and the technical governance?
Yeah, absolutely. So in business governance, I think you heard a lot about just now around PyTorch Foundation, Linux Foundation being involved in a lot of those pieces. Technical governance really is not changing. The idea is to continue the active development we have. That being said, though, the foundation makes it so that everybody can be even more committed to open source PyTorch, right? The fact that we are in the open, we are being developed together. So that means that hopefully more companies, teams are contributing as well. So that's part of this.
Thank you. So talking about contribution again, how do we empower others to be maintainers of PyTorch at the same levels as engineers of Meta?
Yeah, so the first one is actually GitHub first, as Nikita talked about. I think without that, a Meta engineer was involved in every thing that was committed to PyTorch historically. This is a big deal, but we changed that. And so the next steps are really to put more of the things that we're working on in the open, be that release schedules, be that priorities for work streams, all these kind of things. So this is a work in progress right now, but it is what we're looking at.
Okay, thank you. And our community is what makes PyTorch strong here. And Nikita, can you tell us a bit more about submodules and how they help contribute to the PyTorch strength for the ecosystem of the community?
Sure. So like PyTorch is built sort of on the shoulders of the giants. We would not be able to build all the ecosystem if we could not rely on other great libraries that provides foundation for what we do. To give an examples, we have like basically algebra libraries. We have some quantization libraries. We have point-to-point communications between like accelerators. And we rely on all this like contributions from other people and from open source community in general to provide like a reasonable performance experience even for the eager mode. On the other hand, like we want to encourage more contributions. So if you have something that like you think that PyTorch community in general might benefit from, but you don't think it is ready for the general consumption, create a submodule, create an extension that would naturally evolve and help people like make PyTorch available in the new domains.
Thank you. So we actually have a couple of minutes for questions for the audience. If anyone has any questions, I can repeat it for everyone online. All right, so now it's like really future looking. Bit of an open-ended question here for our speakers. Beyond 2.0, towards 2.x, what are you most excited about?
I can go first.
Yeah, why don't you go first?
Yeah. So I'm more excited about the kind of things that we can do with compiler that we haven't thought of, because I do feel from the first principle point of view, if we can generate more code, more kernels, there could be other use cases. So this is really open, and I trust the team is able to come up with something that's really surprising.
Yeah, just briefly, I think the thing that's been so important for PyTorch in my mind is the usability, the debuggability. So that plus performance is really what it's all about. And then platforms. Which platforms do we support?
I want to expand a little bit on Peng's answer, and I'm excited about the code gen for the new types of operations that we'll be able to implement, such as, for example, the operations on the lists of tensors that will allow us to speed up the optimizers, the sparse code gen, the code gen for nested tensors. I think that's going to make PyTorch much more valuable as a research tool.
And I'm excited about PyTorch being available on more and more platforms, right? It would be great to see PyTorch in the space and PyTorch on our watches.
Thank you. I know I'm excited the most of seeing even more contributors coming in on our platform and helping build this future together. So thank you for the panelists. A little round of applause. All right. Good.